Hey, this is chapter 14, and we're going to be focusing on trigonometric graphs. Even though this chapter also covers trig identities and therefore trig equations, those topics are going to be covered in depth in pre-calc, so I will therefore reference you to that topic. So we have each of our basic trig functions, and we're going to be starting with y equals sine x. Now, when we graph this, we get what we call a sinusoid. So we have a wave-like graph in which we have our maximum and our minimum. These are the boundaries of our range, which are -1 and 1. Therefore, our maximum is 1 and our minimum is -1. Our amplitude we define as half the distance between the maximum and the minimum. So you can see here that the distance here would be 2 overall. We're taking half that distance, so therefore the amplitude is 1. Now the period is because the function is periodic, which means that its graph has a repeating pattern, as you can see here by the wave. So therefore, a period is the horizontal length of each cycle, in which a cycle is the shortest repeating portion of a graph. So this part of the graph is the shortest part that does not repeat. As soon as you start, if you start here, as soon as you start going down here, it starts repeating once again in the wave-like pattern. So I'm going to be reviewing those topics again in the next slide, but we can see them also in the cosine graph, and later on we're going to be talking about our tan graph. I'll just mention a few things about that now, but we still have our period, which is our horizontal length of a cycle, and we do not have our amplitude because our range is all real numbers. However, our graph is bounded by vertical asymptotes. So first, let's just talk about characteristics of sine and cosine graphs, and we group these together because they have the basic same form of their graph, in which we have, as I said, a wave-like pattern. So I'm just using y equals cosine x here. But once again, our amplitude is half the distance between m and n, uppercase m and lowercase m, with the uppercase being the maximum and lowercase is the minimum. Now, in our formula, if we have y equals a sine bx, in which a and b are constants, our amplitude we can see in our a constant. So the absolute value of that number is our amplitude, and that helps us out when we're trying to graph. So this is y cosine x, in which 1 is our a value, therefore our amplitude is 1. B goes into the part of the period, so 2 pi over the absolute value of b is the period. So if we're just given a formula and we want to graph it, that's how we would find the period. So once again, the period is the horizontal length of each cycle. The cycle is the shortest repeating portion of a graph. And the frequency is the number of cycles in a unit of time. For example, if you have radio waves and they want to know how many times a certain point passes through another point in 2 minutes, then we have a frequency. So we have our third graph, which is our tangent graph, and this has the same form of y equals a tan bx. But we're going to be using our period in a different way. This time we have pi over b, and our vertical asymptotes we find with pi over 2b.